Okay, hello all. I'm just having a little help session with a student and she has some questions on section 1.6. So we are on page 77 and the first one was question number 9. So this may help you as well. So this question is asking us to factor. And the first thing that you always want to do is look for your greatest common factor. If there's anything that can come out of all three. So remember, we've talked a little bit about terms. So these are terms. And we're seeing that there's only A's in these two terms. So that's not uncommon, but we can see that they each can divide by a 3. So that's the first thing I'm going to do is I'm just going to write that out here to this side. So if I factor out a 3, and I probably did this one blurry. I'm trying to get this to, okay. If we divide out a 3, we have an a squared left in that first term. And then a negative 21 divided by 3 leaves us with a negative 7a in the second term. And then 30 divided by 3 leaves us with a 10 in the third term. And a reminder to everyone, if one of the terms completely divides by the greatest common factor and you are left with a 1, then make sure you put a 1 placeholder right in that spot, because if there's 3 terms, there should still be 3 placeholders inside the parentheses. Okay. So now that we're here, we're asking ourselves, well, how do I know if it can factor or not? Okay. So because A has a squared or bigger, our goal is to try to factor this further. And so that's the second question. So the second question is, how do I know when I am done? That students always ask that. At least I was always asking.
Right.
I didn't even know to ask that question until later on. I was like, oh, how do I even know that I'm finished? Okay, so because a squared is bigger than a 1. So I know that there's still a possibility. When the exponent is a 1 and there's nothing in common between all the terms, then you're done. So I have to investigate. That's why I say to myself, I have to investigate. So now I'm going to ask myself a question. So how many terms is the next question I always ask? And I'm still in the process of getting, I have a factoring flow chart that I'm trying to find in all of my documents somewhere that I want to put up for everyone. That's kind of this, but in a much prettier fashion. So I'm asking myself how many terms. So we have 1, 2, 3 terms we're trying to factor. So 3. So 3 terms tells us we have some options. So I can try to factor this into what we would call like 2 binomials. Okay, and just a little quick example up here of a binomial would be like x plus 2 and x minus 7.
Okay.
That would be like 2 binomials. That's kind of what we're envisioning, like an a times an a, right? Okay, and does the a squared term have a coefficient is what it's called. So we're asking right here, is there something on that A? And no, it is a 1. It's an unsaid 1. So because it's a 1, it can only be a simple A times A. We don't have to worry about anything on that A, okay? Then the next thing is we are basically guessing and checking. So if you think about FOIL, when we remembered how we multiplied our binomials together, right? So if I multiplied this x plus 2 and the x minus 7 example I had up here, I would get x times x, and then I would get an x times this negative 7 at 2 times the x. And so I would have 4 multiplications. I'm just going to write them out so that we can see. So I would have these 2 middle terms that always add to make these 2 terms right here will add to make this middle term in the middle. And then notice that positive 2 and the negative 7 multiplied to make the negative 14, right? So that means if we're going to work this one backwards, we're trying to visualize something like what I have up here in the corner. So I have to visualize factors, which are things that multiply, factors that multiply to a positive 10. Let me rewrite that, a positive 10. And at the same time, if they multiply to make a positive 10, they have to be special factors, because at the same time they multiply to make a positive 10, they have to add to make a negative 7. Okay, so we're going to list all of our factors of a positive 10. Now, the only way that two numbers can add to make a negative is if one is a negative and then one is a positive, or if they're both negative, right? Those are the two ways. And so if I had a positive and a negative, I could never get to a multiplication of a positive. So my only option are my factors that are negative and negative. For instance, -1, -10. They multiply to make a negative, they multiply to make a positive 10, but when I add them, I get a negative 11. So that pair is not going to work, because our goal is that they add to make a negative 7. Okay.
Okay.
So let's look. Another pair is, I just go right down the list. And if you're not confident with finding factors, get out your Desmos that I've been showing everybody how to use on. In fact, I'm just going to show everyone how I would do this if I were going. I'm not quite sure how to. I'm not quick enough at factoring. It doesn't mean that you can't factor, but you know, our factoring this, or the little factoring of this 10 isn't our goal. So let's just try to make this simple as possible. So I'm going to go to my Desmos and I'm just going to start saying, actually, this is, I'm going to say this and put a link up. So I'm going to make a little table for all of us here. I'm going to do a factoring table. So I'm going to say, whatever your number is, you're going to put your number up here. So ours is 10, and then we're going to just divide by the x1. So I'm going to just put in lots of numbers here. So you can see that 10 does divide by 1, and that's 1 and 10. So all the integer pairs are going to be the ones that are the factors. So we've got 1 and 10, 2 and 5, 9 is not, and then we're back to the 1 and 10. So those are our only factors. So we have -1, -10, that didn't work, but we have a -2 and a -5, and that does add to a -7. So this is the magic pair that we're looking for. Luckily, 10 only had 2 sets of factors. So we have a -2 and a -5. Now I'm just going to check my work. This is my final answer, but I want to check to make sure it is in fact true. So if I were to multiply these again, right, I would get a squared. I would get a -5a. On top, I would get a -2a. And then the -2 times the -5 is a +10. And then that's where those two in the middle make that common term of the -7a plus 10. And then we had the 3 out in front. And then if we distributed that back through, we'd have 3a squared minus 21a plus 30. And we can give it a check. We got back to the original.
Okay, so the third one, the a subtract, or the 3a subtract 2, a subtract 5, that is the final answer.
Mm-hmm.
Okay, so I had the one above it, I just didn't go farther on that.
And that's where a lot of students just don't know, like, am I done? And so again, the reason I know I'm done here is because a has an unsaid 1 as an exponent, and this a has an unsaid 1 as an exponent. And there's nothing that I can't factor anything between a and 2 or a and 5. So we're good.
Right. Okay, so I do have a question though.
Sure.
On the third one where you had the two, what are they called, binomials?
Mm-hmm.
Okay, so when you have the two binomials, are you is the two A's, does it come from the A squared to where
Mhm.
it separates the two?
Yep.
Okay, that's where I wasn't sure if it was that or if it was that from the 7A.
Yep. So when I get to here and I said, how many terms do I have? And I have 3, I start envisioning this thing. I start always thinking, okay, because if it works out, like up here, right, the 2 like terms always condense into a third common term.
Right.
And so then that leaves me with 3. So I'm kind of envisioning if this works out, this cross multiplication thing will give me the A squared. That's okay. Then I got to come up with 2 numbers that multiply to make 10, but at the same time, they have to add those middle terms to make the -7.
Got ya.
That's the puzzle. Yep. So we're looking for things that multiply to make 10 and that add to make a -7.
Gotcha. Okay.
So every other odd.
Yes.
Okay.
And I
So-
think I did 13 right. I had 17 I was completely off on. Like there was no anywhere near situation on that one.
Okay, before we go to 17, the grouping, what were there any like 27, 29, were any of those part of it?
I didn't get past 25 to be
Okay.
completely honest.
So let's make a space because 27, 29, those are similar to the one we just did. So that would give us some immediate practice.
Okay.
So 25 was your last one. So that means 29 would be your next one.
Yep.
Okay, so let's look at 29.
Okay.
So 29 says x squared minus x minus 12. And this little set of questions that I ask myself, this is just kind of how I walk through every single time. So my first question again is always going to be, is there a greatest common factor that I could just pull out up front? And there's no
doesn't-
x's, right? And there's no 1, 1, and a -12. There's nothing in common. So my greatest common factor is 1. Okay, there's where we are.
Okay.
I always ask myself, do I have to investigate? I do, because there's an x squared.
Okay, so I have a quick question. Why is the greatest common factor 1?
Because there's not an x in each term, so I can't factor out an x. And the greatest common factor that will divide a 1 on this x squared, an unsaid 1 on this x, and then a -12 is 1.
Got it. Okay, that makes
Yep.
sense. I was wondering where the 1 came from.
Yep.
Got it. Okay.
And that's just kind of just validating that I'm kind of stuck here for the moment. And then here, once I get to here, I'm like, well, I got to keep investigating because there's a 2, an x squared, and that
Right.
can always be made by some kind of an x and an x. And I have,
And that's
3.
where you make the binomials, right?
Yep. So I'm thinking if it works, it's going to be something like this. And that's 2 because there's a 1 on this x squared. So there's nothing, if I were to multiply these, they will get me back to the x squared, x times x.
Right.
I'm always envisioning that FOIL, that multiplication with the binomials that you would have done, I think, in lessons 1, 4, 1, 5.
Mm.
Okay. So now that we're here, we're like, okay, well, I have to come up with things that multiply, right? To make a -12 factors. And after I make that list, I want them to add to make a -1, the thing in the middle. Okay. So this is really, they call this ax squared plus bx plus c. So, and if you always label these, the coefficients and numbers on your x squared, the number on your x, and the number on your constant, a, b, and c, it's always, if you want to write this down, it's always factors of c that add to make b.
Oh, okay.
And it's really factors of AC because A is a 1 for us right now. A doesn't really play a role, but it's really, if you want to look at the big picture, it's really AC, that multiplication, but we don't, right now, 1 times a -12 is still just a -12. So numbers that multiply to make a negative, I know it's going to be plus and minus, right?
Mhm.
Okay, so let's just list them all. We've got 1 and a -12. And sometimes people get really good at this where they don't have to make the whole list. They can figure this pattern out, but we're gonna make a list. Okay, so we've got 1 and a negative 12, 12 and a negative 1. We've got 2 and a negative 6, a negative 2 and positive 6. And then we've got 3 and a negative 4 and negative 3 and a positive 4. And then I'm right back at the flip-flop, right?
Right.
This is my exhaustive list. So if I go through and I add these, I've got a negative 11 and a positive 11. And then I've got a negative 4 and a positive 4, a negative 1 and a positive 1. And we want the positive 1, or the negative 1, sorry. We want the negative 1. So
So
this
it's
is,
3 and negative 4.
yep. And then we just plop them right in.
So it'd be x plus 3 and then x minus 4.
Yep.
Okay.
And then you could always check your work by validating that they multiply. So I'm just going to outline this because this is our final answer. But I'm going to check it because that's going to be x squared, a plus 3x, a minus 4x, minus 12. And those add to make the negative x in the middle.
Okay, cool.
Okay.
That makes way more sense.
Okay, good. Yay. So I just want to go do one more of these because 33 is a kind of a weird anomaly. And I think that's going to be your next ad.
Yep.
And so that one is 16 minus 6x minus x squared. So it feels weird to have, for me at least, it always feels weird for me when my x squared is negative and it's on this side. I'm used to x squared starting out the whole gig, but
Right.
this is really C and B and A, because A is always the value on your x squared. Okay, so I'm just going to check my GCF. Is there anything I can factor out of these 3 terms? Okay. And I don't see anything because of the 1 there. 1 is the only thing that divides into both 6 and 16. So
Right.
one is our greatest common factor again. So we're envisioning the binomials like you mentioned before in the last one. And now instead of making a positive x squared like last time, we have to make a negative x squared. So what do we know has to be true then?
That it has to equal -1.
So it would have to be a negative x and a positive x, right?
Oh, see, now you're really getting me.
Because this x squared is a negative, so it'd have to be a negative and a positive to multiply to make a negative x squared.
Okay, so positive x. Okay.
Now,
So this is where you have to try and find the 16, and then it has to add up to this -6.
yes, you got it. So it's going to add up to a -6. And we have this -1 here. So when we multiply, we just have to check because that's going to make things maybe flip-flop. So let's just write out all of our factors of 16. So we have 1 and 16, and they could be both negative, right? Both positive or both negative. 2 and 8, -2,
Okay.
-8.
How do you know if they all, is it the both positive, both negative? You can, when can you only do negative? And when can you only do positive?
Well, you really could always do both and then just add them up. I mean, if you, you could, I think once you become more fluent and comfortable with the strategy, you will start to notice, like, I know it has to be both positive or both negative because I have to multiply to be a positive.
Got ya. Okay, I got you.
Yeah, so if one was positive and one was negative, they would multiply to make a negative, so that won't work.
Gotcha. Okay.
Okay. So -2, -8, and then we have the 4. So we either have -4, or +4, +4. And that's our list for those. And then I'm going to add them. So we have 17, -17, 10, -10, and then 16. Oh, I got to add them, Sarah. -8 and 8. Okay, so none of these work, right?
Correct.
But but it may work out because we might have to use where one of the factors is positive and one is negative because of the fact that this is the negative x squared here. So when we do our FOIL thing, this negative is going to make one of the middle terms negative. So let's also list, oh my gosh. There we go. It keeps getting blurry. So let's say we had a -1 and a +16, that would give me 15. A 1 and a -16 would give me -15. A -2 and a +8 will give me a +6, and a 2 and a -8 will give me a -6. So it actually has to be this one, 2 and a -8. If it
Okay, so
works
it
at
does
all.
have to be the opposites.
This one does, because see how we usually have a positive x squared and it's a negative x squared. And it's hard to envision. So we're trying to just get our, it multiplies to be a -16, but let's, so I think if we put the 2 and the 8 in there, if we do the positives, if we put a +2 and a +8 in there.
Oh, I see what you mean, to see if it comes out where it's the,
right.
I got you.
Yeah, they multiply to make the +8 to +16, but because of this negative right here, this right here, we're going to get a -8x, right? When we multiply. So we're going to get the 2 times 8 will be the 16 out in front. And then we have a -8x, we have a +2x, and then we have a -x squared. And then our like terms do give us the -6x.
Okay, I'm kind of confused on how you got the -8x. Never mind, I see it.
That's
Never
right.
mind. I just saw it.
This one is like, yeah, it's flipped around, so it feels very weird. So I'm just gonna circle here the final answer up here.
I had my 16 over way too far, and I was totally missing that part.
That's okay.
So your final answer is there. Okay. Okay.
So that might give you some food for thought.
Yeah. So
Then-
that's kind of what, like, if you look at number 21, that's kind of what it's broken down into, where I have to just put it into a binomial, right?
21.
Yeah. Is that something like where I would have to just go kind of backwards like we were doing from here?
So let's go back to the ones you said, what were the ones earlier? You said,
17 was the first one that I got totally confused on.
okay, so let's go to 17.
I gotta rewrite it because it looks like chaos on my paper right now.
It was a 2x squared, and that's an x plus 5 plus 7x and x plus 5 plus 6 and x plus 5. So I'm just going to underline my terms. Terms are separated by an addition and subtraction. So we've got this whole thing is a term. And there's terms within there, but then this whole thing is a term. And then this whole thing is a term.
Okay.
So when we're asking our original question on the GCF, we're asking, do these three terms have anything in common?
Yes.
What do
The
they
x
have?
plus 5.
Yep. So they have an x plus 5. So that whole binomial in parentheses, x plus 5 comes out in front. And then you can do a parenthesis or a bracket here. And then what's left over from the first term is 2x squared. And then what's left over from the second is the 7x. And then what's left over from the last is the 6.
Okay.
And then we're going to ask ourselves, are we done?
There's no, you're not done because you still have a x squared.
Right. So there's still a possibility of the two binomials because there's three terms here. Okay. So I'm just going to bring this x plus 5 out in front here. That, that stays out. And then I'm going to hope for two binomials. Just
Okay.
set myself up. And sometimes it's a little bit of a guess and check, but we do have some strategies that we can use. Okay. So I'm reminding myself the only way I can make a 2x squared is a 2 and a 1, right?
Right.
So I know my only possibilities, if it works, is a 2x and an x. And then there's going to be something and a something, but we don't know what those are yet.
And you don't know if they're plus or minus yet.
Well, we can pretty much guess that they're plus because they have to add to make a positive.
got
And they
ya.
have- and they have
Okay.
to multiply to make a positive.
Gotcha.
So we're looking for numbers that multiply to make 2 times 6, because we have to take into account the A out in front.
Okay.
Because when we FOIL this whole thing, right, we're going to have these numbers out here are going to multiply with the 2 and then the insides. So 2 times 6. So that will be 2 times 6, which is 12. And then they still have to add to make the 7.
Okay.
With me on that?
Yep.
So I'm just going to list them 1 and 12, 2 and 6, 3 and 4. Well, that's easy enough because the 3 and the 4 are the only ones that make the 7, right?
2 and 6 and 3.
Mhm.
Yeah.
So,
Okay.
so it's not just 3 and 4 that go here. It's actually the 3 And then it's gonna be 3 and 4 end up adding to make 7, but 2 of that 4 is in here, right here. So this 4 is
Oh, it would be a 2.
right. Yep. And then the 3 will have to go here. And they have to go in this way because you needed the 2 and the 2 to multiply to make the 4, and then you need the 3x to make the 3. So,
3.
yep.
So that would be 2x would be 3x.
So I'm going to show you down at the bottom. So the ones up here at top, we could have flipped those around and it wouldn't have mattered, the 2 and the 8.
Mhm.
I'm going to show you why down here it does matter. Oh gosh, it's done. Okay, so let's say I put the 2 here and the 3 here. If I multiply these, I'm going to get 6x and a 2x. I would have still had the 2x squared out in front, and I'd still have this 6 here, but I'd have 8x in the middle. And we don't want that. We want the 7x.
Okay.
So that's why we have to put the 3 here and the 2 here. So what I do is I just kind of use my fingers to do some checking. Like when you get your hair cut and the lady like checks your hair, right? Like, does this side match this side? I just kind of use my fingers and go, do these 2 multiply to make 2x squared? And
Okay.
they do. And
Right.
then I ask my outsides, do the 2 last ones multiply to make 6? And they do. And then I do the middle. So this makes a 3, and this multiplies to make my 4, and that's what adds to make my 7.
Got it.
And
So
you
then
can-
your final answer is actually the x plus 5
Yep,
x to the second 7 times 6. Okay,
yep.
got it. Okay, so I think I got it, but I'm afraid think I got it, but then I don't when I go to another
Let's-
problem.
Let's do, I think then we did 929. What about, did we have, what about the ones in the middle, like 19 or 21?
I have 21. I don't have anything for.
Okay, let's check out 21. Because, so 21, this gets our last case, our last scenario that can work. Well, for what
Okay.
we've been working on so far. We always look for the greatest common factor if there is anything. You see anything?
No.
No, I always look and see if there's a constant here, but I know there's not because they don't have any letters the same. And
Got
then-
ya.
yeah, and
So it
so,
would just be 1 then.
yeah. And then I know I have to investigate because I have some kind of an x squared here, right?
Mhm.
And so, the x squared, and then I always ask how many terms. And there's 4. And because there's 4 terms, the only strategy that we can use is the grouping strategy. And grouping, once you learn it, it's like, oh, I totally got this.
Yeah, that's where I was like, no clue.
Okay, so if you look here, it's like, oh, you can see some things in common, but not everybody. So like these first 2 have an X in common, right? And then the
Mhm.
middle 2, they have an X in common. The last 2 have a 3 in common. So you could really mix and match any of them. Usually, I'm being honest with you, usually the way the problem's given to you, if you just do the first two and the last two, it usually works out fine.
Okay,
So I'm asking myself, what's in common between the first two?
the X's.
So the X. And so if I divide out that X from the first one, I have an XY left. And if I divide out an X from the second one, I have a 1.
Okay,
And now I'm going to do the same for the next one.
so the X on the outside, that's just the greatest common factor out of those?
Yep,
Okay,
yep. And then the next two terms, what is the greatest common factor between these two terms?
that would be 3.
Yep, so we're just going to put a +3. Make sure you put a plus there.
Yep,
Unless they both have a negative in common, but they just had a +3. And so then when you factor out that 3, you have an XY and a 1, right?
right, because it would be. Okay, see, that's where you confuse me though. Why would it be a 1?
Because 3 divided by 3 gives me 1. There has to be a place. Yeah,
Oh,
because you're you're dividing out the 3 and you have a 1 XY, and you divide out the 3 and you have a 1.
got it.
You got to have a placeholder.
That's where it got me mixed up because we kept the 3 on the greatest common factor part, but then changed
Mhm.
it to a 1 because we had to divide. Got it.
Yeah.
Okay.
And so now, if you can kind of look at this in a 3D view, now what do these two terms have in common?
XY and 1s.
An XY plus 1.
Mhm.
So that whole binomial comes out just like we did on the last problem.
Mhm.
Remember, they had an X plus 5 in common right here.
Yep. So that would be on the outside.
Yep, so the XY plus 1 comes out front. And now what's left over is the X plus
Plus
3.
3.
You got it.
Okay. Yeah, that may see what, yeah, when I saw that, I was like, this makes absolutely no sense. Like when we did 17, it just looks like so much, and then it really isn't because they're all the same in the middle.
Right. So this is probably going to be enough food for thought. Now wait. Maybe not. So I want to go to let me find some of the ones. Okay, so you were okay with like problem number 1?
Yeah, I got
Difference in
1.
squares?
Yep, I was 1, 5, did okay,
Okay,
and then 9 is where I started going
Okay.
down.
so you can tell me, but I'm thinking this might be enough to get you going. And
Okay,
then I'm available on Sunday evening.
Okay.
Or Monday evening. So if you want, if we can schedule something, the earlier we schedule it, the better, just because I can set aside the time. So if you could maybe text me
Gotcha.
tomorrow, or even let me know now, like if you just want to pick one and we just go, okay, let's just do this. Then we can meet, I'll email Mr. Sandlin, and then we can meet and then do more, like check in and then do more in the 1-7 and the 1-8.
Perfect. Okay, yeah, awesome. Because I have that, and then I have 3 more coming on next Tuesday that I have to get into also.
Okay,